Okay, this section is on summarizing and graphing data. So the PowerPoint is going to go through definitions and show you some different examples, and then the next video actually has how to actually do a problem with examples. So we have a frequency distribution or frequency table. It shows how a data set is partitioned among all of several categories or classes by listing all of the categories along with the number of data values in each of the categories. So what we're going to use to look at these is the total points scored in the Super Bowls. This is all of them from 1967 to 2018. So I took the points scored from each team, added them together. So we have this group of data here. So this would be a frequency distribution of that data. So the frequency for a particular class is the number of original values that fall into that class. These over here are your classes, 21 to 30, 31 to 40, and so forth. So for this particular one, I've done 6 classes. And then to get the frequency, just go back to the original data and count. So like between 21 and 30, you would count how many numbers are between 21 and 30. So those are, here you've got 1, 2, 3, 4, 5, 6. So that was the 6th, and then keep going, count 31 to 40 would be 10, and so on and so forth. Your lower class limits are the smallest numbers that can actually belong to the different classes. So in this case, we would be 21, 31, 41, and so forth. Then your upper class limits are the largest numbers that can actually belong to the different classes. So in this case, it would be 30, 40, 50, so on. The class width, which most people think is the difference between the lower class limit and upper class limit, but it's actually the difference between 2 consecutive lower class limits, so it actually goes down this way. So 21 to 31, the difference is 10. 31 to 41, the difference is 10. So it is not 9. You have to go down vertically. So the class width would be 10. Class boundaries, which there's a couple graphs that use class boundaries. Typically, I don't really use class boundaries when I'm graphing and stuff, but I think there's like one example that actually uses the class boundaries. Those are the numbers used to separate classes but without gaps. So the lower class boundary is found by subtracting 0.5 units from the lower class limit, and then the upper class boundary is found by adding 0.5 units to the upper class limit. So if you take 0.5 away from 21, you're at 20.5, add 0.5 to 30, you're at 30.5, and so forth. So those would be your class boundaries, and like I said, I think I have one example on here where I use those, but typically I don't. Typically I just label things with the classes. Class midpoints are the values in the middle of the class and can be found by adding your lower class limit to your upper class limit and dividing by 2. So in this case, if we do 21 plus 30 divided by 2, we get 25.5. 31 plus 40 divided by 2 is 35.5, and so on. You have a relative frequency distribution. That includes the same class limits as a frequency distribution, but instead it's replaced with a relative frequency. The frequency is replaced with the relative frequency. A proportion, it can be a decimal or a fraction, or a percentage frequency where you just switch it to a percent. So if we use our original frequency distribution here to make a relative frequency distribution, we take, there's been a total of 52 Super Bowls, so you take your frequency divided by your total, so 6 divided by 52, that gives us 0.115, and I rounded these to 3 decimals. And then 10 divided by 52 is 0.192, and so on. When you do relative frequencies, this should add up to 1, but I think on this one it actually adds up to 0.999 because I've rounded to 3 decimals. You sometimes get a little bit of a rounding error. So as long as it adds up to 0.999 or 1.01, you're okay. Sometimes they'll come out to 1 even if you've rounded, but that one actually adds up to 0.999. You can also do the percentage frequency instead, so basically just switch those decimals over to percents. So same thing, you would do your frequency divided by your total. So like this one starts, so 10 divided by 52 is 0.192, and then multiply that by 100 to get the percentage. You get 19.2%, and so forth. And again, percentages, they should add up to 100%. This one, same thing, the rounding error, I think it adds up to 99.9%. Sometimes you add up to 101%, but as long as you're just like 99.9 or 100 or 100.1, you're okay. It's just a little bit of a rounding error. Cumulative frequency is the number of values less than the upper class boundary for the current class. It's a running total of frequencies. So I've seen this different ways. It says the upper class boundary, so technically I guess you should say less than 30.5. Use the boundaries on this, but it makes more sense usually if you use the next, what would be the next class, lower class limit, so less than 31. Because it's strict. So how many do you have that are less than 31? Well, that would be 6. How many do you have that are less than 41? Well, that would be 10. You could use the 30.5 and 40.5. The answer would be the same. Oh, sorry, I said that wrong. Less than 41 would be 10 plus 6 is 16. But so for these, usually I just write the next lower class limit instead of the class boundary. So basically this is just a running total. So less than 51, you would have 16 plus 10 plus 6, which would be 32. And then less than 61 would be 10 plus 16 plus 10 plus 6, which would be 42. Less than 71, keep adding them up. 8 plus 10 plus 16 plus 10 plus 6 would be 50. And then finally, when you get to the next one, your next class limit, if you had another class, would be 71 plus 10, which is 81. Or if you're using the class boundary, it would be 80.5, but they mean the same thing, so I don't know what difference it makes. That's why I write it this way. It should be the total frequency you have once you get to the end, because you've added all these up. So there's been 52 Super Bowls, so the very last one will be 52. So just cumulative frequency, cumulative running total, that's all you do. Just start at the top and keep adding as you go down. So just so you can see the different frequency tables side by side here, you've got your regular frequency distribution. You've got this one's percentage frequency, the relative frequency. You could do decimals or fractions, too, it doesn't matter. And then there's your cumulative frequency. So to construct a frequency distribution, you need to, step 1 is determine the number of classes. You'll have to do this on your homework, and I'm going to do in the other video, there's an example of me doing one of these, which is what you have to do for your homework this week. It says to determine the number of classes, should be between 5 and 20 typically. That I tell you, I'll say construct a frequency distribution with, 10 classes or whatever the case is. To calculate the class width, and it says always round up, that's the big thing. Even if you don't get a decimal, you still have to round up, otherwise it doesn't work. So you take your maximum value of your data minus your minimum value of your data, divide by the number of classes, and that's how you get your class width, and you round it up. Choose a starting point. Most of the time, the easiest thing to do is pick the smallest data value, start there. That's your first lower class limit. And then using that first lower class limit and class width, proceed to list your other lower class limits, because remember, class width actually goes down. So for our case, we started with 21, the class width is 10, so you go 21, 31, 41, 51, and so on. And then once you have all those, then you can proceed to enter the upper class limits, and I'm going to show you this in just a second on our example that we've been using. And then you can do a tally, or you can just go through and count to get the frequency of each class. So if I back up here, actually, I think I have it on Excel. Let me go to Excel. So for this data, so I've got my data. On the PowerPoint, it's not in order, it's just all listed there. Sorry, that got blurry. So it'll focus again. Our minimum data value, this is in order from least to greatest. So our minimum data value is 21. And if we go down, our maximum data value is down here, it's supposed to be 75. There it goes. So 21 to 75. So what you do to find your class width is you do 75 minus 21, and on this one I was doing 6 classes. So 75 minus 21 gives us 54. Divide that by the number of classes we want, which is 6. 54 divided by 6 is 9, and you have to round up. Even though it's a whole number, you still have to round it up to 10. And so by doing that, then what you would do is, get back to it here. Let me just use this one. This one's fun. So then what you would do is, if you ignore this for a second, you pick your smallest data value to start with, so that would be 21, and then we just set our class width as 10, so we'd go down this way and do 31, 41, 51, 61, 71, that's 6. So there's your 6 lower class limits, and then go through and fill these in. So you can either add 9 if you want to, or usually what I do is, if this is 31, that's 30. If this is 41, that's 40. I just take one away from the lower class limit. Usually subtracting one's easier. In this case, not very hard either way, but most of the time it's easier just to take one away. And then after you have your class limits, or your classes, I mean, then you go through and count to get your frequency. And like I said on the video, the other video, I'm actually doing one of those so you can see that. So you have different types of distributions. You have a normal distribution, which we talk a lot more about later, which is the bell shape. Uniform is data that's evenly distributed. Skewed means that data is bunched up toward one side or the other. The tail is longer on one side. So normal distribution, the total points of the Super Bowl is actually a normal distribution. You can see the frequencies start low, they reach maximum, and then they come back down. It's roughly symmetric about the maximum. You do have this stuck out here, but it's okay. It doesn't have to be exactly symmetric. As long as it approximately makes this bell-shaped, then it's a normal distribution. Uniform distribution, you see these kind of go up and down, but for the most part they're all relatively close together there. Skewed distribution, these always confuse me, so I made these images here. This data is bunched all up to the left, so this is skewed to the right because the tail's to the right. This data is all bunched up to the right, so it's skewed to the left because you've got this little data out here that's making it skewed. So whichever way the tail goes is the direction the data is skewed. So skewed to the right, skewed to the left. We use what's called a histogram to analyze the shape of the distribution. That is basically a bar graph where the bars are equal width and they're drawn adjacent to one another so they can't have gaps. The horizontal scale is the classes and the vertical scale is the frequencies, and then the heights of the bars corresponds to the frequency values. So in this case, so I've already showed you this histogram, I just didn't call it that, but it's just a graphic version of your frequency table. So this is where some people will use midpoints or class boundaries to on the horizontal axis. I just label it with the classes. I think that makes it more clear, in my opinion. Instead of using other things, I just think it makes more sense just to use the classes. You should always title a graph, label your axes and everything. Basically, you want it to be so that any reader that looks at it would be able to understand it, even if they, you know, hadn't had a statistics class or something. Like they need to be able to understand it. So that's why I also think it makes more sense to use your classes instead of anything else. So you do draw the bars that are equal width. Now, when you draw this by hand, I'm not the best person at drawing by hand. I try to use Excel as much as I can because obviously it makes it perfect, but as long as yours is roughly equal, then that's fine. The big thing is don't put any gaps. I do put the lines here because if you don't have the lines, it just looks like a blob. So at least define these lines so that you can see each bar. And if you know how to do Excel when you graph these, you can. So the bars on the horizontal scale I already talked about. You can use any of these, but I just use the classes because I think that makes it make the most sense. And then the frequencies on the vertical scale. Relative frequency histogram, same thing. This is using the percentages. You could use the decimals if you wanted to, but it's the same thing. You just switch the vertical scale to the percentage frequency or the decimal. but otherwise the graph should look the same because it's from the same table, so it still has the same shape and everything. So this also discusses other types of statistical graphs. On your homework this week, I think I only have you making a frequency table, and then I'm going to do some of the graphs on the examples, but I don't think, yeah, I'm pretty sure you don't have to make any graphs this week, because next week we're going to discuss like mean, median, mode, and all that good stuff. And then the week after that, there's like a little project for you to do where you are going to have to graph. It just makes the most sense to kind of put all the graph stuff together. So you will be graphing in a couple weeks, but just so you can see what other types of graphs are. I guess the project kind of ties the first couple weeks together. That's what I'm trying to say. Our objective is to identify a suitable graph for representing the data set. Now typically, obviously you're in a stats class, so I will say, I won't just say make just any graph of whatever. Like I'll specifically say you should make a pie chart or a stem and leaf plot or whatever. So like you'll be told what to do. But typically if you have to pick a graph to make, you want to make sure that it's effective in revealing the important characteristics, and you want to make sure that it's easy to read, which I kind of touched on. So you have what's called a frequency polygon. This uses line segments connected to points directly above the midpoint values. So here's the class midpoints for our total points scored in the Super Bowls, and then you put a dot. So the first class had 6, the second one had 10. And then you connect them with a line, so that's called a frequency polygon. Relative frequency polygon is the same thing, except you use the percentage, or again, you could use decimals if you wanted, but I've got just percentages here. So it should look the same as the last one, it's just using the percents instead of the actual frequencies. And it depends on who you ask. This is said pronounced ogive or ogive. This is a line graph that depicts your cumulative frequencies. So this is where it uses the class boundaries, which I said I didn't particularly use all the time, or very much. So the class boundary was 20.5, 30.5, 40.5, and so forth. So you use the class boundary, so 20.5, that we don't have any numbers below. They start here. So 20.5, they start at 21, so there's no numbers below it, so that's 0. And then if you do 30.5, which is the same thing as less than 31, less than 30.5, and less than 31, because we're talking about points scored, you can't have decimals and stuff, those are the same. So that would be 6, and then less than 41 or 40.5 is 6 plus, or 10 plus 6, which is 16. And then less than 51 or 50.5 is the 32, and so on and so forth. So that just shows you the graph of your cumulative frequencies. A dot plot, this consists of a graph where you have a number line, basically, and then dots. You put a dot for each data value you have. So every dot corresponds to a different data value. So this actually allows you to get the original data values from the graph. This one you can't get the original from because all you know is that there are 16 less than 41. All 16 of them could be 35. You don't know. Well, I guess you do know that less than 31 is 6. So all 10 of these could be 35, I guess I should say. But you don't know what they are unless you actually have the original to look at. This allows you to get the original data back, because for 50 you've got two 50s, you got 151, two 52s, let's see, two 45s, three 46s, and so forth. So some graphs you can obtain your some visual representations you can obtain your original data, some you can't. Stem and leaf plot, or a stem plot, most everybody knows about stem plots. That organizes and groups your data, and that one also allows recovery of your original data. You have to have at least 2 digits. So to construct a stem plot, divide the digits into your stem and your leaf. Align your stems in the vertical column from smallest to largest, and then put your leaves on the right. And you need to also include a legend on this. So in this case, 2, 3, 4, 5, 6, 7 is my stem, which is my tens place, and then my units place, and my ones is over here, my leaves. So this, you have to have your data in order from smallest to largest, and then you list out each one. You don't do any commas or any gaps, you just write the numbers. And then you need a legend so that somebody looking at it knows what it is. So like I did 3 bar 7 means 37. So this also allows you to recover the original data. It also shows you the shape of the data. Like you can tell when you do it this way, if it's bunched up, or if this would be normal. If you draw a line here, it kind of does that bell shape. You know, if you flipped it upside, or flipped it on its side, because it goes like this and then it goes back down. Bar graph uses bars of equal width to show frequencies of categories of qualitative data. Your vertical scale is your frequency still, or relative frequency. Horizontal scale is your categories. And multiple bar graph has 2 or more sets of bars and is used when you need to compare 2 or more data sets. So this is an example of a bar graph. So does your education contribute to your salary? So if you've completed 9th grade, high school, and so on and so forth, it shows you how much your salary, your average annual income, goes up the more education you have, hopefully. A multiple bar graph when you're comparing. So this is male and female. You're comparing the 2 groups, the males and the females. And this was your median income. A Pareto chart is a bar graph for qualitative data with the bars descending in descending order according to their frequencies. So it should, for Pareto chart, it should go from highest to lowest always. This one always looks like it's about, I think they're about even. Sometimes I think that one looks higher, and then sometimes I think they look even. But it is supposed to go, it's okay if they're even, but you have to go largest to smallest for a Pareto chart always. Pie chart shows the relationship of the parts to the whole. You need to label those with percentages. Still make a title and make it easy to read. So this is an example of a pie chart. This is for hours spent on the phone after 5 p.m. And it should always have your percentages. You should never just make this and then leave it alone. It's too hard to understand if you don't have percentages there. Scatter plot or scatter diagram is just your paired XY data. Horizontal is your x-axis, vertical is your y-axis. You can use a scatter plot to determine if there's a relationship. Time series graph is data sets composed of similar measurements taken over regular intervals over time. It does go in chronological order. Time is always on the horizontal scale, and then whatever you're talking about is on the vertical scale. So like for instance, this one's the Dow Jones. It shows you over these years. And so like I said, time is always the horizontal, and then whatever else it is that you're doing is the vertical. So for rules for any graph, you should always provide a title. You should always label your axes. You should always identify units of measure, and it should be clear, like I said, to somebody that's, never seen a graph or never taken a math course or a statistics course. They should be able to understand it if they, might have to think about it for a second, but it needs to be clear. So some graphs are bad because they contain errors. Some graphs are bad because they are technically correct, but they're misleading. So you need to be able to recognize bad graphs. The news reports and stuff, they like to use technically correct information but make it a little misleading sometimes. So if you have a non-zero axis, when it starts at something other than 0, the difference is exaggerated. So for instance here, if you start at 53, so Democrats were at 62, Republicans 54, Independents 54. So this exaggeration looks huge, but really when you put a 0 down here and start it, it's really not that different. Pictographs. Pictographs are hard to interpret sometimes because they're drawings and they're busy and they're three-dimensional, and it kind of makes data look distorted. So you can read this here. So the bars do have equal width on this, but really it's, number one, it's horizontal, and that's usually harder to read anyways. And then it's kind of busy, so it makes it a little more difficult to understand. Most people prefer bar graphs that go up. It's easier to understand when they go up. This one here, this is one-dimensional data with three-dimensional boxes. The last box is 64 times as the first box, but the income's only 4 times as large. So this one would actually be a better graph to use for that same data, because it goes from the smallest to the largest in this case, and it makes it a little bit easier to understand, and it's not so busy and distracting. And so that's all for the PowerPoint. So this is posted. You can look it over too. I went kind of quickly, and then the other video, like I said, actually has where we are going to make a frequency distribution and do some graphs. So I'll slow down in that one.